Welcome to TalkTensors, the show where we unpack the most interesting and impactful research in machine learning.
Great to be here.
Today, we're diving into a paper that's tackling something, well, pretty fundamental. How do we get these incredibly powerful language models to understand not just, language, but also data that unfolds over time? I mean, time series data.
Yeah, the stuff you see everywhere, healthcare, finance, transport.
Exactly. And think about how much smarter AI could be if it could look at, say, a company's earnings report and its stock price chart together.
Or a patient's medical notes alongside their ECG readings. That kind of integrated understanding is often missing.
Right. And that's the core problem this paper tackles. Current models, they kind of struggle to reason across both time series data and the text that gives it context.
That's the gap. So this deep dive is all about a new framework they're proposing called ChatTS.
ChatTS. Okay. And what's the big idea behind it?
The core innovation really is integrating time series tokens directly into the vocabulary of a large language model.
Okay, so instead of trying to describe the time series in words.
Exactly. You give the LLM native tokens for the time series patterns themselves.
That sounds much more direct. What are the benefits they're aiming for?
Well, the main goal is enhanced reasoning across both types of data, the text and the time series, without, and this is key, without damaging the LLM's existing natural language abilities.
Makes sense. You want to add a skill, not trade one for another.
That precisely.
Yeah.
And to make this actually work, they've also developed some crucial resources.
Ah, the supporting materials.
Yeah, there's a TS-Instruct training dataset, a TS-Instruct QA-Gold dataset for evaluation, and even a quantitative probing set. They've really tried to provide the groundwork.
That's quite comprehensive. So they're not just proposing an idea, they're building the tools for it too.
Right. And the training approach is designed specifically to add this time series capability while preserving that core LLM reasoning power we rely on.
And how does it perform? Early results.
Pretty promising, actually. They're reporting state-of-the-art performance on tasks that need this multimodal reasoning.
Okay, fascinating. So before we dig into the mechanics of ChatTS, maybe you could take a quick step back. Put this in context. How did we get here in terms of analyzing time series data?
Sure. It's been quite an evolution. I mean, for decades, it was primarily the domain of traditional statistical methods, ARIMA, exponential smoothing, things focused on trends, seasonality. Think back to Macrodakis and others in the 70s.
Right, the classic approaches.
Then came the deep learning wave. We saw RNNs, LSTMs, eventually transformers getting really good at sequence modeling, and people started applying them heavily to time series forecasting, imputation, anomaly detection.
So specialized neural nets for sequences.
Exactly. But while powerful for specific tasks like forecasting, these models often didn't have the broad reasoning or natural language understanding of, say, a big LLM.
Okay.
So more recently, especially with the explosion of LLMs, people started thinking, hey, can we use these amazing language models for time series too?
Which led to that approach you mentioned earlier, converting the numbers into text descriptions.
Yeah, that became a common strategy. Models like LLM Time, for instance, encoded time series as text strings for forecasting. Others fine-tuned LLMs for specific tasks like classification.
But it always felt a bit indirect, like a workaround.
It often was.
Yeah.
You're essentially forcing numerical patterns into a linguistic format.
Yeah.
And you inevitably lose information, fidelity, the subtle shapes, the precise magnitudes. It's hard to capture all that perfectly in words.
Like describing a complex graph over the phone, maybe?
That's a good analogy, yeah.
Yeah.
So the aha moment for ChatTS seems to be realizing maybe we don't need to translate. Maybe we can teach the LLM the language of time series directly.
Make it bilingual, in a sense.
Kind of, yeah. Fluent in both text and temporal patterns. And a big bottleneck holding this back, honestly, has been the lack of good training data sets with time series and relevant text paired together.
Which makes those data sets they created potentially quite impactful for the whole field.
Absolutely. It's a major contribution just on its own.
Okay, so let's get into the framework itself. ChatTS. How does it actually achieve this integration? You mentioned adding tokens to the vocabulary.
That's the core mechanism. Think about an LLM's existing vocabulary. It's full of tokens representing words, parts of words, punctuation.
Right.
ChatTS essentially says, let's add new tokens to that vocabulary. Let's call them time series tokens, VT, alongside the language tokens, VL. So the full vocabulary V contains both.
Okay, so the model now has building blocks for both text and time series.
Yeah, exactly. And then you train it like a standard LLM using auto-regressive prediction, predicting the next token in a sequence. But now that next token could be a word or a time series token.
So it learns the relationships and flow between text and the time series data simultaneously.
That's the goal. The challenge, of course, is doing this while maintaining the model's natural language understanding and achieving good time series understanding.
How did they create these time series tokens? Turning continuous data into discrete units sounds tricky.
They opted for a method they call a discrete tokenizer. The key idea here was prioritizing reconstruction accuracy over, say, maximum compression, like you might see in other areas like image or audio tokenization.
Meaning they wanted the tokens to represent the original data as faithfully as possible.
Precisely. So what they do is they take the expected range of the time series values, say from -s to +s, and divide that range into a fixed number, K1, of bins or buckets.
Okay, like sorting values.
Yeah. Then each individual data point in the time series is mapped to the index of the bin it falls into. So a sequence of numbers becomes a sequence of bin indices discrete tokens.
Got it.
They also add a special token to mark the end of a channel for multi-channel data, and then flatten the whole thing out. They compared this to other methods like VQ, VAE, and found their discrete approach gave better reconstruction.
Makes sense if accuracy of the representation is the priority. And what are the training data, the TS-Instruct dataset?
Right, so they needed data that had both time series and relevant text for instruction tuning. They actually used GPT-4 Mini to help generate this. They took time series data from existing archives like Lonafan and TSC,
Okay.
showed it to the model as images and metadata, and prompted it to generate realistic conversations involving reasoning, classification, decision-making, even math analysis based on that time series data.
Ah, so synthesizing the kind of multimodal interactions they wanted the model to learn.
Exactly.
Yeah.
And for evaluation, they created the TS-Instruct QA-Gold benchmark. That's a multiple choice question answering data set, but with human annotation to ensure quality.
Crucial for reliable benchmarking. Okay, so they have the tokenization, the data. How did the experiments pan out? What were the key results when they tested ChatTS?
Well, they compared it against several baselines on their TS-Instruct QA-Gold dataset. Interestingly, their 8 billion parameter ChatTS model, trained with their method, outperformed several much larger models, including some closed source ones like GPT-4 Mini, on the time series reasoning tasks.
So size isn't everything. The specialized training really mattered.
It seems so. It really highlights the benefit of directly integrating the time series data and doing specific instruction tuning for these kinds of tasks.
And what about those closed source model comparisons?
They were careful to add a caveat there. Because they use GPT models to help generate their training data, there's a risk of data contamination or overlap, which could inflate the performance of those models on their benchmark. So those results are more for reference.
That's good practice to acknowledge. Did they look at other model types?
They did mention testing some visual models in the appendix. Those actually performed quite well, likely because the dataset generation process involves showing images of the time series plots.
So the benchmark inadvertently favored models good at vision because of how the data was made.
Potentially, yes.
Yeah.
Which contrasts with other studies that found vision models struggled with synthetic time series reasoning tasks. It just shows how sensitive results can be to the evaluation setup.
A really important point about benchmarks. What about the core LLM capabilities? Did adding time series tokens hurt its language skills?
That was the key validation they did. They tested ChatTS on standard NLP benchmarks like MMLU Pro and Big Bench Hard, and they found its performance was largely comparable to the base Llama 3.1 8B model it was built on. Expanding the vocabulary with these discrete tokens didn't seem to significantly degrade its natural language processing abilities.
That's a huge win. You get the new capability without breaking the old one.
Exactly. They also did ablation studies, looking at different training data combinations, and found that models trained on both their synthesized TS-Instruct data and a general instruction data set like OpenOrca performed best overall, showing good robustness.
So the combination of specific time series instruction and general instruction following was important.
Yes, models trained only on time series data struggled more with following the natural language instructions in the tasks. They also used GPT-4o to judge the quality of the text outputs.
As an evaluator.
Yeah. And ChatTS versions trained with the combined data got higher scores for helpfulness, relevance, and accuracy in their generated responses.
Very convincing. But no model's perfect. What limitations did the researchers themselves point out?
They were quite upfront. One area is accurate time series generation, like forecasting. That remains pretty challenging.
Which isn't too surprising, maybe. Forecasting is hard.
Definitely. Another point was about normalization. They normalize the time series data for training, which is standard practice, but it means the model doesn't directly see the original real-world values. This can be a limitation for tasks needing very precise numerical answers based on the original scale.
Ah, right. The units get lost in the normalization process.
Sort of, yeah. And finally, they noted weaker performance in zero-shot time series classification. So classifying a time series type without specific examples beforehand.
So it needs some examples, maybe few-shot learning to do well on new classification tasks.
That's what they suggest, along with potentially using longer context windows and just getting more diverse labeled classification data. So definitely room for future work.
Absolutely. But overall, it sounds like a really solid step forward in getting LLMs to genuinely understand and work with time series data.
I think so. It addresses a key limitation in a clever way and provides the resources to build on it.
Okay, this brings us perfectly to our novel notions segment. Based on ChatTS and this idea of integrating time series tokens, let's brainstorm a bit. What's a potential, maybe slightly out there research direction this could enable?
Okay. Well, building on this idea of time series understanding, what about time series imagination?
Time series imagination, intriguing. Go on.
Could we push a model like ChatTS beyond just analyzing existing data? Could it learn to, well, imagine plausible future time series, or maybe fill in missing gaps in data based purely on textual descriptions or other context?
So, like asking it, given this company's new strategy described in the press release, show me a plausible trajectory for its stock price. Not necessarily a perfect forecast, but a realistic scenario.
Exactly. Or maybe for a patient, based on their history and this new treatment plan, generate a likely recovery path for their vital signs. We know LLMs can generate creative text and even images.
Right.
So if you train it on enough paired data, the time series, and really rich descriptions of what's causing those patterns, maybe it learns the underlying dynamics well enough to generate new plausible sequences.
That could be amazing for scenario planning or even for generating synthetic data in low data situations. What's a less obvious angle on that?
Maybe generating counterfactuals, like what might the patient's ECG have looked like if we'd administered this drug 2 hours earlier? Generating that alternative timeline could be huge for causal reasoning.
Wow, yeah. Understanding cause and effect by imagining alternative histories. That's powerful. The challenge is there, obviously, capturing the real-world randomness and complexity.
Oh, definitely. It's probably low to medium probability in the short term, but longer term as models improve. Who knows?
A fascinating possibility. Okay, got another one.
Second idea. What if we treated time series as a language for physical systems?
Okay. Unpack that a bit.
So the discrete tokenizer in ChatTS is fairly simple, right? It bins values. Could we develop a much richer, more formal language for time series? Think specific patterns, motifs, events as the words or grammar.
So instead of just binning individual points, you tokenize recurring shapes or patterns. Like this token means sharp peak followed by slow decay.
Precisely. Treat those characteristic shapes as semantic units. If the model learns this language and connects it deeply with the textual descriptions of the physical processes involved, it might gain a much deeper understanding, maybe using hierarchical tokenization or even learning a formal grammar of how these temporal words combine.
What could you do with that deeper, more structured understanding?
Imagine diagnosing a machine fault, not just from raw sensor data, but from the AI describing the narrative of the sensor readings in this formal temporal language. We observed an initial transient spike, followed by a sustained high-frequency oscillation.
Okay, I see. It provides a more meaningful abstraction layer.
Right. Or controlling robots using high-level commands described as temporal patterns. Maybe even a universal translator that recognizes analogous patterns across different domains, seeing the same boom-bust cycle pattern in economics and ecology, for instance.
That's a really cool idea, finding universal temporal structures. Again, sounds challenging.
Medium probability, maybe. It needs big leaps in representation learning and integrating that into LLMs. But it could change how we fundamentally interact with complex systems.
These are fantastic, thought-provoking directions. Yeah. It really shows how work like ChatTS doesn't just solve a problem, it opens up new questions.
That's often the sign of impactful research, isn't it?
Definitely. So to wrap up, ChatTS feels like a significant step towards AI that can truly handle multiple types of information seamlessly.
Yeah, combining that powerful LLM reasoning with the rich, dynamic information locked away in time series data. It's unlocking a deeper potential for understanding the world around us.
There are clearly still challenges, as the limitations show, but the potential is huge.
Absolutely. Lots of exciting avenues for future research.
And for everyone listening who wants to get into the nitty-gritty details, we've put a link to the actual paper in the show notes. Definitely worth a read.
So the question we'll leave you with today is this. What new insights, what new capabilities might we unlock when our AI can truly speak both the language of words and the language of time?
And just a quick reminder, our Novel Notions segment is purely for brainstorming and entertainment. We're exploring ideas, not making predictions. Thanks for joining us on TalkTensors.
Until next time.